Ready? Good morning. I'm Jeff Hammond, Executive Director at International Ground Source Heat Pump Association. Thank you for joining us for September's Dig Deeper webinar. We're thrilled to have Brock Yordy with us presenting again. And thank you very much, Climate Control Group, for sponsoring this Dig Deeper webinar. Climate Control Group is the manufacturer of Climate Master geothermal heat pumps, as well as IEC fan coils and ClimaCool modular chillers. So thank you for sponsoring this webinar. Before we get started with Brock, we have just a few updates for all of the IGSHPA members who are joining us. The latest IGSHPA news has changes all the time, so I want to make sure everybody's up to date. If you're interested in these town hall and dig deeper webinars and would like to speak, we are accepting abstracts for 2024. Just contact us at info@igshpa.org and we'll provide the details. We've had great success with sponsorships this year. We have one left for 2023. It's a town hall webinar. All the others are filled, but we do have openings for 2024. So let us know if you'd like to sponsor one of these dig deepers. The advantage is that these are recorded, so your sponsorship will be out there on the web for quite some time. The 2023 conference is up and running, and we're getting a lot of interest. Time goes quick, so don't miss that early bird special pricing. The special pricing ends on November the 3rd. Go to igshpa.org if you'd like more details on the conference. In Las Vegas, we're working with National Groundwater Association again this year, and our conference is December 5th through the 7th in Las Vegas at the Convention Center. I'm thrilled to say that we have filled all of the sponsors, and we couldn't do this conference without these sponsors. We just recently filled our diamond sponsor with Loop Tech, a driller out of Texas, and we certainly appreciate that. We appreciate all of our sponsors, and we're looking forward to seeing them at the conference in December. Same thing on exhibitors. We are about 2/3 full now, so we need to make sure that if you're interested, you contact us as soon as possible. There's still quite a few really good locations left on the exhibit hall floor. And this is a great location because there are doors right here to the right. As soon as the show opens, you'll have traffic here, and there are doors up here at the top. The NGWA floor is right along here. So great location if you're looking to talk to drillers or other attendees of the conference. There are still some advertising opportunities for the program guide. Most of our full page ads are already taken. We have a couple left, but we still have quite a few 1/4 and 1/2 page ads left, and we have the inside cover and back cover as well. Again, details on igshpa.org for that. The conference agenda is online. We have a lot going on with the agenda. We're thrilled to have our keynote speaker from the Department of Energy, Alejandro Moreno. And I think that'll be an excellent presentation. There's just so much going on with DOE right now, and especially the Geothermal Technologies Office. So we're looking forward to that. Conference awards. If you haven't voted yet and you're a member, that voting ends the end of this month. We'll be awarding 1 residential innovation, 1 commercial innovation, and 3 awards of excellence. There's a link on the conference page at igshpa.org. If you're not already a member and you'd like to vote, just contact us, and we'll step you through that membership process. Same thing here on IGSHPA Board of Directors. This is open for members to vote on the next set of IGSHPA Board of Directors. We are still taking nominations through the end of this month. Voting will start around mid-October. And if you're interested in running for the Board of Directors, just contact us, and we will get you on that slate. This year, there are 4 board seats open: the architect engineer sector, the ground heat exchanger installer sector, and we have 2 new board seats. We're expanding from 5 to 7 board members. So there's a manufacturer sector and a utility sector this year. And those will be announced at the annual general meeting at the conference. So let us know if you'd like to be part of that. The research conference has extended dates for abstracts. We now have until October 1st for submitting abstracts for the research conference. and those will be reviewed starting on October 18th. The conference itself is in Montreal in May of 2024. Really happy to announce that Geo Outlook magazine is back. It's been on hiatus for a couple of years, and it will be announced next week, as a matter of fact. So watch your inbox for this September digital edition, and we'll be at twice per year at first, eventually moving to quarterly. So you'll see a January issue next. This one has a lot of really good information, so I'm excited to make sure to have everyone see this. I think you'll be pleased. As far as CEUs and renewals, if you'd like points for this webinar, just send your name and your email address in the chat, and we'll keep track of those. Your email and your name is all we need for that. If you happen to be watching this as a recording, we are now providing credit if you're watching that recording. If you are attending live, don't worry about it. You don't need this number. But if you're watching this recording, you'll need to report this number right here along with your name and email address, and we'll get you credit for this even if you're not able to make it live. Just some housekeeping. If you would, please use the chat for questions. I will be mentioning those questions and giving those to Brock at the end of the presentation. If we don't get to all the questions, then we'll contact you later on. If you would, please mute your microphone unless you're speaking. And as I mentioned, this is recorded. So at the end of this session, we'll be uploading it to the website. You should see it in the next couple of days on the IGSHPA website. Just go to the publications menu and you'll find the recordings for the town halls and the Dig Deeper. One more slide and we're ready to start our exciting presentation today. This is a disclaimer and potential conflict of interest, just to make sure that everyone knows where we stand. The upcoming presentation represents the opinion of the presenter and does not represent any official position, opinion, or endorsement of any products or services by IGSHPA or its members. IGSHPA town halls and Dig Deeper webinars are for member updates and education on the latest information in the geothermal heat pump industry and are not meant to endorse one technology or brand over another. It is the presenter's responsibility to disclose any conflict of interest or position that may arise in the content of the webinar. Normally, this is when I would read Brock's bio, but he's very modest and wants to move on. So I'm going to let him have control of the presentation. And also, I want to thank again Climate Control Group for sponsoring our webinar. So with that, we'll turn it over to Brock. Thank you very much for presenting today.
Okay, am I in presentation mode?
You are. Looks great.
Wonderful. Yes, I am modest. I do have a quick screen with, and it doesn't want to. There we go. I pressed the button 3 times. Let's see if it does 3 slides. I'm Brock Yordy. I'm an industry advocate and writer for the industry. I'm a 3rd-generation driller. I've worked for a bunch of big industry individuals for drilling. And I've also developed training and worked for several of the large rig manufacturers. My current job that pays the bills, that I'm very thankful that they've allowed the time, is Venture Drilling Supply. And I do business development and training development for them. And they allow me the time to travel. Right now, I'm in Georgia at the Georgia Groundwater Professionals Conference, where I'll be talking today and tomorrow. And a big piece of that talk will be about diversifying your business into geothermal so that I can be in front of those water well drillers that are so elusive to us at times. So today we're going to talk drilling methods, solids handling, solids disposal. And we're going to start with drilling fundamentals because I don't feel like we pull the curtain back and actually look at this from the scientific and physics side. Drilling is very self-taught and tribal. Learned it from my grandfather and my father. And, as I went to my first drilling school at 20, I thought I knew everything. And then as I interned for Halliburton and Bayreuth for 4 months, I realized I didn't know that much. And by the time I finished the course in fluids and drilling and engineering, 11 months later, I had a completely different perspective that goes back to my roots of everything that we need to know that's simplistic, but how we can make micro changes that will really determine the cost and the efficiency and the effectiveness of how we choose drilling methods. So we're going to start very basic here. And I had a slide like this last month, and it's that basic to borehole creation. It's very much a cutting action, no different than if I'm going to drill a hole in my wall or a hole into concrete. We have a bit that's creating cuttings that are manageable, and then we're applying pressure exerted by the rig and the tooling. And then I'm going to pump a fluid, if that's an air, if that is a drilling fluid that is water-based, if that is a high frequency. Those are all the ways I am going to facilitate the moving of those cuttings away from the bit face and up the hole. So if I'm thinking about what is the goal for me as a driller, as a collaborator on a job site, as we're completing this bore field, a hole is not a hole unless it's open, which means it's going to create solids and waste that we got to manage. It needs to be stable so I can get that loop to bottom. It needs to be straight in the desired direction. And obviously we're playing with angles, and that changes our physics and hydraulics of drilling. Needs to be gauged so that we're putting the right amount of grouting material around there, and that we're not influencing outside of our bore field that we want to. Clean, as in I'm able to easily get that material, my loop, my grout, everything in, so that I have that simple product installation, and then I have efficient production and extraction. Those are our goals, and each one of those can be directly influenced by our drilling methods. So if I start thinking about, what is determining factors to my method? Obviously, the big one is geology. If I'm in the Canadian Shield, what type of cutting action and weight do I need to be able to cut that granite? Gets into if I'm in a coastal area. I was just in Kiwa Island yesterday on a 12-hole residential geothermal project where the formations were very fragile, where we went from sands and gravels into some seashells and coastal stuff into a marl. And if I had exerted the same pressure that I'd used to try to drill that granite, it wasn't going to work. And that's where we get into, from mud rotary to casing advance to air to foam to sonic. It's got to be the right tool for the right application that's minimizing the impact, so that we can continue to make the bore field what we need it to. So formation hydraulics, the way I can break the fracture of the ground, is very important to the stabilization of our hole, how we're going to get loops in, how we're going to influence the transmissivity of that loop field as we continue. Next, depth to water. That's very minimizing the impact. We talk a lot lately about, air is the way I want to go. I don't have to have a drilling fluid. I can manage these cuttings into something. But when I start producing water out of the ground, let's face it, every New York Times article and Washington Post article right now is all about groundwater, because it's a protected resource that we need, and it's not infinite. And we need to understand, when we start producing water out of the ground, what damages are we having? And finally, location, footprint, our neighbors, how is that drilling method going to determine what we get into? And obviously I have 50-ish minutes to have this discussion, and we're going to touch on some of these, but please send emails. Let's talk. There's lots of collaborations we can do, from the point of noise mitigation to what is the right application. So after I get through looking at what my site is going to impact me wise, what does my equipment look like? And first comes up, if I think of this as a drilling system, and the only piece that's not on here right now is the driller, and we're thinking very much how we train these new drillers and how we work forward. So rig capabilities, but truly it comes back to rig limitations. What is my rotational torque? What am I able to make for a cutting? What can I pull back for toolings? What type of string weight I can have? What pull down, what pressure can I exert without deviating the hole and making it, a crooked hole? And obviously the more pressure we apply on surface is going to start flexing those drill rods and causing us to not have a straight hole. Next, fluid pumping capacity. Is that my drilling fluid that's water-based? Is that a foam? Is that using a mud pump? What type of air compressor? We get into air compressors. How much fuel burn per hour am I increasing to the job site? How much can I bring out of the ground? And then frequency, when we get into what we can do with sonic tooling and that stuff. And that moves right into tooling. What does my borehole look like? What is the diameter of my hole? What type of rods? What type of fluid can I push through those rods to exert the right amount of pressure to bring cuttings out of the hole, but not damage the borehole? And then finally, our bit selection. That's exactly what's making it so we can manage to get to the bottom of the hole effectively, get tripped out, and be able to install loops and grout. So this is not a geology course, and since college and all that I did with geology, I think craft beer has very much impacted how I identify rocks these days. And I know there's a couple geologists that I've seen pop in here. I'm going to break it back down to what we really need to know, and that's how can I drill it? How can I not? Can I break it? Can I not break it? Can I minimize that impact? And it starts with our non-reactive formations. So that's our sands, our gravels, our rock. They have porosity, they have pore space. We have to minimize the pressure that we exert if it's air or mud, and how it goes out into the formation and creates, a larger borehole erosion. I need to look at my permeability. How easily can I move fluid through it? And then cutting action. Again, this is why we see so many different types of bits, and we're going to jump into bits next on site, but it's how can I cut it? What does my particle size look like? How can I dispose of that? How can I remove it at surface? What is the weight? I get out west, I can get into iron pyrite and get into many other aspects that are really going to impact what I need for pressure to be able to move those cuttings up out of the hole. Depth is 100% impacting that. When we went from 300 to 400 to 600 to 800 foot boreholes, it takes more fluid at gallons per minute and PSI to be able to evacuate that hole. And what size solid do I want to make? Again, if we jump from there, we think reactive formations, and many of the projects we get on, we go, oh man, there's a bunch of shale, or, oh no, there's a lot of reactive clay. We can chemically control those. We can remove the water factor that's going to make them sticky and swell or break down. And it comes to us recognizing, they can take a little bit more damage. They're non-porous. Fluid doesn't want to move through them. We just have to understand what's going to swell, what's going to break down, what's going to be sticky, and what's going to affect my drilling fluid volumes to do it. If I look at my non-reactives with the dependent of being heavy particle sizes, when we get into some of the denser rocks, about 1 gallon of fluid will move 1 gallon of cuttings out of the hole. And a 5-inch hole is about 1.02 gallons per foot. When I get into reactive formations, and as they take on water and they swell and they get sticky, I move into the 2 to 3 times that. So 3 gallons of fluid to make that flowable as I try to mix it up. And that's very important as we look at our reactive geologies throughout the country. And again, cutting action. What type of bit am I going to use? What can I have happen downhole? How can I end up getting stuck? And what type of solids do I want to make? The drilling process will always be disruptive. Many times as drillers, we say, it's just going to be a muddy job site. But we can manage these things. How do we minimize the impact that we're going to have on that? So if I'm thinking my, idiot's guide to drilling non-reactive soils, what am I thinking about as I look at this log? I look at a USGS log, I look at a test well log, sands and gravels. First and foremost, what is my stability? What is the influence that I'm going to impact? How can I erode? How can I end up using more grouts? How can I end up with a bigger borehole than I need? How can I slough that in and have poor installation issues? Those are why I'm thinking mud rotary, when we get east of the Mississippi and then into the upper Midwest, is very predominant. It's because it's been very low influence and it's pretty cheap to operate, other than now we're getting into a disposal issue. If I get into rock, solid size, Am I using a hammer? Am I using a PDC? How am I creating that cutting size to make it a 1/2 inch to an inch to make it come up out of the hole? What does that formation density look like? That's going to tell me my timeline. How many minutes per rod? How many hours per hole will it take when I get into these rock formations? And then again, cutting action is going to be exactly what's going to determine our project success on rock. And this slide in reactive geologies was something I built with the US military. We were sitting around a table and the team just starts shouting out everything that is going wrong on this project we're doing in Jordan. And it very much was clays and shales. They're going to react differently. Some are going to be weathered when it's going to break down. It's not going to be that hard to get out of the hole. There's other times where it's going to want to be sticky and reactive, and it hasn't seen water in a very long time. So the amount of fluid that we give it allows it to become alive. And then that's where we get into sticking drill pipe, plugged bits, cutting sizes, surface areas that start to bind together. A boot formation, that's where we start bringing cutting sizes. They bond around the stabilizer or the tooling, and we're not able to get that fluid up out of the hole. And then it starts exerting pressure on the outside of the borehole, and we end up losing fluids, inadvertent returns. We get an increase in fluid density because, again, they want to go back to their colloidal size, which is going to make them part of the drilling fluid and increasing that solids content. So what can I do? I can prevent these reactivities, these breaking downs, these sizes with the right fluid design. If that is air and a clay inhibitor, or if that's a mud that's got a chemical inhibitor, and we use surfactants and soaps, and then we also use partially hydrolyzed polyacrylamides called PHPAs that wrap around them. And that's things we have to consider as we're looking at how we're going to drill this and what influence we're going to have. So I look at that pumping nature, and then I jump right into bit selection. And what do I need? And this is a great diagram from the old days of Atlas Copco, but you're looking at, what are our cutting actions? And I like to think of our bits the same as our teeth. I'm a fat kid, and I like to eat. And, as we look at what we want to cut, that is a clay style, a soft formation, I'm using the front of my teeth and I'm thinking like an apple, and I'm going to bite it and then I'm going to chew those pieces into smaller. Now, if I get into rock or denser formations, I need something that's more like my molars, and I'm going to take a bite and then I'm going to have to grind that up into a point that's going to be easy to swallow. And that's when we get into bit selection. We have endless technology from the oil field and other industries now that we can apply. And it's funny, I say now, they're all 40, 50 years old. Garen Eubank is talking about PDC bits in the mid 90s. And in Ball State, we were like, wow, these PDC bits are the greatest thing ever. And they're like, yeah, these were all built in 1991. And that drives us right into cutting size, solids creation. And deciding on the size and scope of the job. You can see in the far left corner, I have a blue-green shale that we drilled on straight air because they had been doing mud on that project, and these were geothermal boreholes. And it would react so poorly, it would take them 2 days to drill a 400-foot hole. But we were hydrating it. We were allowing it to react, and you can see the sand size particles and then the solids control units. So the oldest technology we have here is our tricone bits. And, this is really what allowed Howard Hughes to be crazy, was the patent on this tricone bit and the ability to be able to have that cutting action with the skirting and be able to go from a mill tooth, which would be what I would use for those soft reactive formations, to a button, which would be like my molars to drill rock. The big piece that we've lost along the way is our jetting action. And part of that is from fluid flow. And for the geothermal industry, that 5 to 6 inch hole, we only really need about 150 gallons a minute to maintain the right uphole velocity. And we'll get into that. But a big piece of the bit life and being able to maintain good production rates is having that ability to force the cuttings away from the bit face and up around the rod so that we can get them to surface and remove them. And that requires PSI and jets. And so jetted bits are still a very important aspect. We've just somewhere along the way lost that in tribal knowledge and wanting flow. And there's plenty of places where I get into reactive formations where if I can have the jetting action, and this doesn't mean we need to go out and buy a big bad oil field piston pump. It's just allowing to have enough of the right force exerted at the bit face to keep it clean to move up hole. This is what happens often when we are unable to jet and we over penetrate. If I don't have jets, I have to slow down my penetration rate, increase my rotation, and I'm going to have more time per foot in order to maintain what I need to stay successful and not have a plug bit and trip out. And we see this. We see this on jobs, plenty of places, in young drillers over drilling into a dense clay formation, and then we end up pulling pipe and pulling these sleeves of clay. And again, this is no different than if I'm going to make a smoothie. What do I need to do after I put my ice and my milk and my bananas and everything in there? I can't start it on high rotation and think I'm going to start a good cutting action. I have to ease into it, but I also have to ease into how I'm going to penetrate. So ideally, we want a bit that is able to move the cuttings away from the bit face. When we don't, all too often, those abrasive solids create heat, start us on that path of deviation, and we're no longer able to maintain the production we want. So we're using that fluid to move the cuttings away from the bit face so that we can keep it clean, keep the cutter heads going. The other half of this is, as we continue to drill these more complex boreholes, is if we have a drilling fluid that is full of solids on surface that we're sending back down, we're doing the same thing and we're causing as much damage. And we'll get into that. My nice, neat animation is not working, so we'll just move in. This is definitely what we do not want to have happen. Drag bits. Drag bits are a desired piece of tool that we need on surface in some places, but depending on from a single wing to a chevron to the way, it's all about cutting action and slow penetration. And that's what I'll say about drag bits. But this is not slow penetration. We're trying to make a cutting that is going to be the size of a quarter, 1 inch in diameter. Polycrystalline diamond compact, or PDC, can stand for pretty darn costly. There's plenty of these bits out there, and now we have hybrided them with drag bits so that we have the winged capability of cutting, soft formations, but also when we get into that competent limestone or shale, we can make good hole with the diamond cutters. These bits work fantastic if we have the proper weight on bit, which means we're using stabilizers. We can't use pull down on these. By the way, to running a bit like this is those diamond cutters make very small cutting sizes, which when we go to disposal takes more surface area for the fluid to move them up hole. And it's a much finer material to separate out, which means we have more pumping off and disposing we do by the end of a job. And this is a balance. And there's many places where these are successful, and there's other places where a button bit can do just as well. There's endless possibilities with what we can have for PDC bits these days and where they come from around the world. Hammer bits, and we could talk for an hour to 2 hours on hammer drilling and foams and cutting sizes. The big thing here is depth to water. That's going to impact my action of this bit. A lot of times, a 6-inch hammer is a small hammer. And then if you look at a 3.5-inch or a 4-inch drill rod, it's very hard to have the annulus, that space between the drill rod and the wall, to make those cuttings come up out of the hole effectively. And so it's very much of a balance of how we're going to design a system if we're going to get into hammers and how we're going to use them. For all the drillers out there, I know they're saying, Brock, we defy physics all the time because we don't believe in it. And we can make these work. And yes, I see them work, but at what sacrifice and what destruction are we doing to that bottom hole tooling, not to mention the formations. So pumping action, this is where it comes down to when I'm looking at what an effective, can I get 1,600 feet of drilling a day done, or if I'm going to get 800 feet of drilling a day, and how am I reducing my costs? So we saw this slide, we got the cuttings moving out of the hole. We're trying to maintain that 1-inch size cutting, size of a quarter. So when you're talking to your drilling contractor, or you are the drilling contractor, you know, and we're having that discussion, mud rotary, water-based drilling fluids, we are using a mud pump to force cuttings out of the hole at 60 to 150 feet per minute. That is optimal uphole velocity. That is not going to deteriorate those solids. So when they come to surface, they can be easily shoveled out, or they can be taken out by a shaker screen. Multiple ways. Everybody, we look at air and we go, heck yeah. Why the heck wouldn't I want to be at 3,500 feet per minute uphole velocity to 7,500 feet? And I think of Stan Lee and Spider-Man, and I go, with great power comes great responsibility. Because here's the deal. Competent formations will take that force. But we get into fragile formations. We get into any place where we got all these beautiful inland lakes, and we knew 14,000 years ago there were glaciers sitting here. It's going to be a big deal to make sure that we understand the competency of that borehole and what it takes to move those cuttings out of the hole without forcing them out. And then we get into water. And as we exert that water out of the hole, how do we deal with it and those fine solids? So if air is an option because water quality fractured, we can go to a augmented air drilling practice called foam. And in foam, I can use a foaming agent that is NSF standard 61. There's no PFAS or anything like that in it. And I can make a shaving cream-like consistency that'll bring cuttings out of the hole. I've done 24-inch holes to 2,000 feet with the military using foam. They nicknamed me Captain Bubbles. I own it. You know, and then I can even get into specialty foams at 100 feet per minute uphole velocity that use a bentonite and a foaming agent to do that. And if you're hearing the horns in the background, I'm on the Savannah River, and there's great big freighters going by, so I apologize. Specialty foams allow us to have a very low hydraulic impact, the same as a 200 feet per minute foam with using shaving cream like consistency. There's no influence to those fragile formations where we may have void spaces or something that with air or a 8.5 pound drilling fluid would break that fracture gradient and our cuttings would go out instead of up. And then as soon as we stop that pumping action, what happens? Those cuttings come back into our hole, they stick our pipe, and make it so we can't get loops in. So what happens when I don't have that optimal uphole velocity? The cuttings break down at the bit face, and then as they go up. And I like using the money analogy because it's costing us time, it's costing us fuel, it's costing us horsepower, it's deteriorating tools, it's deteriorating equipment on surface. And so our penetration rate's going to slow. That means we're not going to get the footage we wanted today. We're not going to stay on schedule. We start depleting the specialty polymers we needed to make sure those reactive soils didn't break down and start getting sticky and swelling and making that boot. You know, we increase that fluid density. We start building up downhole, and we either force the hole to destabilize out, we plug the bit, or we stick pipe. You know, and we've all been on projects where we've seen they've had to go back in the hole 3 times to ream it out, or we've had to go back in, or we've had to drill our way out. Those are all situations of high solids and not the right optimum uphole velocity. I like to think of this no different than you know, the space program. And if I'm going to have optimal uphole velocity, and predominantly mud rotary will dominate what we need to do in our industry, because we have lots of mud rotary drillers and they're nimble, and it's less specialty equipment requiring less operational costs. It may not be the most 21st century technology, but it is reliable and low impact. So if I'm looking at mud pumps and I'm looking at my bore field and my depth, and I have a mud pump that's only allowing me 60 feet per minute uphill velocity. I need a fluid that's moving faster than that on those denser solids to maintain that solid not deteriorating so that it's moving at 60 feet per minute. Size and scope, we can see on a test hole a 400-gallon mud pan with a desanding cone, going to a solids control unit or multiple solids control units, and how we manage that site. So when I get into solids control and solids management, what do I need? I need to be able to remove that stuff from the hole so our hole's open. But now, how do I handle that fluid so that I can continue to drill? Even if we get into water hammers, how am I reusing the water that's in my water hammer? Am I running it through centrifuges, or am I going back to a straight water? Everything comes back to the solids that we send back down hole are going to incorporate with the new solids and create problems. So if I look at solids creation, and I'll just jump through this very quickly. Yesterday, I was on a job that was 10-foot rods. It had a 5-inch bit. They were moving 2 5-gallon buckets per rod. A 5-gallon bucket is about 0.7 cubic feet. When we start talking cubic yards, there's 27 cubic feet in a yard, 7.48 gallons to a cubic foot. 0.5 cubic feet is a skid steer bucket. So as we go on the George Lucas project with Midwest Geothermal, at the end of the day, there were 2 dump trucks loads, 2 10-yard dump truck loads of solids that had to be moved. And this is where as we look at how we're building our jobs out, and what obviously there's not many 10-inch holes we do, or even 8-inch holes, but even if we look at from a 300-foot hole to a 600-foot hole to an 800-foot hole, I'm going to have at a 4.5-inch hole at 600 feet, I have 2.45 cubic yards of material that's there. That's not counting the fluid that I brought out of the hole. That's not counting the displacement at the end of the hole. That is just the material so that I have an open hole to put the loop that I need to put in. Is there some deterioration, and do we force some into the formation? Yes, but we cannot plan around hope and luck on something like that. This was yesterday's project on Kiawah Island. 5-inch holes, 250 foot deep, not inch and a quarter, 1.25 cubic yards. And this was Kiawah Island. Anybody that knows ocean course, golf course, top 5 in the country. I know Jack's on here. Jack plays golf. This house is 6,500 feet, and it has 12 boreholes. That's 15.14 cubic yards of material that has to be disposed of. Luckily, on this job, the way it's being manifolded in, a lot of that material can be put into that trench. If we just think of this as a 12-inch hole, or 12 holes for a home, now let's think of a thermal network where we have a very small space that we're going to put 50 holes, and they're going to be 5-inch to 600 feet. What does that material look like? And we can't wait till the end to be able to put it into a trench. So how do we take semi-dry solids that we can dispose of easily along with the fluid we created, and how do they get disposed of? Alternatively on that, thermal networks, these urban green spaces and whatnot, we've done a really good job of making parks and building super fun sites and doing some things. And now we got to go back and talk about the heavy metals, the forever chemicals, the Gen X chemicals, those things that are going to require a T-clip test and special disposal that can impact our cost. And that's a very big piece for us to all think about. So if I go to circulating volume and solids creation, that same 4.5-inch hole that I had 2.45 cubic yards, so half of a skid loader bucket. With my fluid, I'm actually at 3.67. So how do I dispose of that additional fluid? How can I reuse it? What am I using for my solids management? And obviously, with everything we're doing, we want to be responsible environmental stewards, and we want to use the least amount of fluids possible in order to maximize our efficiencies, our impact on the environment, and our profitability. So if I look at that solids control program, and that's getting into our most basic systems like a mud puppy up to much more complex systems that use high G linear shakers, what am I asking myself as a drilling contractor? What is the total fluid volume per hole? I calculate it. Then I set that limit if that's 15, 20% over. What is my method? How do I maintain the drilling fluid properties required? How do I maintain a water quality that's under 10 NTUs so that I can run it back through a hammer? How am I using water additional to dilute out so I can keep drilling? And this is where we get into that self-taught tribal aspect of, oh, I'll add 100 gallons of water and that's going to reduce my mud weight. And we're not looking at it as a mass balance equation of I'm adding 800 pounds, 100 gallons of water, 834 pounds to a system that at 1,000 gallons, 9-pound mud is 9,000 pounds. We're not reducing there. So that becomes our fluid disposal. And I'll tell you what, Badger right now loves the heck out of all of us. And we can see that from the Chicago suburbs of $6,000 a truck with a union driver to the last project that I was seeing in Ohio where they came in and it was, $3,200 a truckload. So what happens? I start, and we're going to talk mud now. I start with a drilling fluid that is 98% water, and it's been augmented to have a viscosity somewhere between 35 and 45. Water is 26 seconds per quart. It has a mud weight just a little over water. Content's good. As I continue to drill and I incorporate solids and I bring things out of the hole, we have breakdown. And so we start to see the hole is becoming clean because I sent down something that weighed almost 8.5 pounds and I had something come back that weighed 10 pounds. That's good. That means the hole, I'm getting the cuttings out. I can make it to bottom. I can set my loops. I can do what I want. But now I need to remove that 12% solids that I just created, or that 13% solids out. How am I doing that? Is that a shovel? Is that cones? Is that shakers? So if I'm looking at being a good neighbor, I'm on a project that's residential. How many days do I have versus a thermal network versus a large scale geothermal project? How am I handling this? Is it from a mud pan to a couple cones to going into a large unit that can clean? My production is fully dependent on how fast my system can remove those solids to continue. If I design it correctly, the volume of my borehole and my circulating volume is about 1.5 times. So that 5-inch hole, it's going to take 400 gallons. I'm going to use 735 gallons so that I have circulating volume because I have something that can clean. I need something that can handle many types of solids that are breaking down. What does that capacity look like? So we get into that solids management, and this is before we dispose of it. This is how we get to how much we're going to have to dispose. I have passive. That's that mud pan. That's that earthen pit that we used to see a lot of. We're waiting on time and physics to settle those cuttings out. And physical, I got a shovel, and my assistant is shoveling away. And that physical labor aspect, that ergonomics, the impact risk mitigation of how many days in a row can we do that, or how many holes in one day. And then we get into that mechanical system and how can it be able to clean multiple holes at one time, 2 rigs running off one. How do we balance that system? So here's passive. You can see the guy shoveling. You can see the big earthen pit. Here's some mud pans. They both have hydrocyclones on them that are removing some of the finer solids, but it's still dependent on shoveling. The big thing with earthen pits and these portable mud systems, they're very good. And we see how they can be utilized. I've utilized them all through the Chicago suburbs with great success of not making a big muddy site. But, it is definitely rate of penetration plus solids is going to equal time. How much time does it take for me to remove those? How much physical horsepower is it going to take? Why is that important? So we get to this point of setting loops. And ideally in the water industry and many of the industries where I need to remove a resource from the ground at the end, I need to have a drilling fluid that's less than 9 pounds per gallon. Why? Because at 9 pounds per gallon, I am 5% solids. I want you to think about the grouts we spec on jobs and back to the days of when we were still doing 250 or 400 pounds of sand and bentonite, and what the solids content, 400 pounds of sand with 72% solids, right? So if I have this loop with water in it and I'm trying to set it and we have this stinger or we have our weights to offset that buoyancy, and now I'm trying to trip into the hole with this and I have 13% solids, a 10-pound mud weight, you can absolutely see why we're fighting it into the hole. Not to mention what else, how am I going to get it in? What could slough off? So it's very much dependent, as I'm drilling this, of maintaining something that's truly, I'd love to see under 9 pounds. What can we live with? Somewhere between 9.5 and 9. 9.5, 10% solids, we're going to fight every loop into the ground. And as we design different loop systems, or we try to put 2 loops in one hole, or all the different ways we can look at that, the closer I can get back to a specific gravity of 1, that 8.34, that's where I want to be. So the components of a good solids control unit, I need a pickup pump, I need shakers, I need desanders, I need desilters, underflow shaker, and I need to be thinking about my disposal. So here is a big breakout, but the easiest way to think about it, and we can start on, the top left, and those are our shale shakers, and they're taking out all of our material that is 225 microns, 80 mesh. That is big stuff. Sand particle size is 74 microns. So that first sweep coming up out of the hole, I want every big solid that I possibly can to get out. Next, it's going to fall through those screens, and it's going to be picked up by our cones. And our cones are separating everything from 74 micron to about 50, a D50 cut, 40 to 50 microns. And that is taking those solids out so that I can maintain a fluid that's not going to damage my top head, my tooling, isn't going to cause downhole issues. And then depending on where we are in the country, I may even have to have a finer cut again with some desilters to be able to remove that out, or get into centrifuges. There's plenty of other ways that we apply this, but those solid sizes are going to depend on what it's going to cost to dispose of this at the end. Boy, did I put a lot of arrows into that, building it. My goal is to have a pile of cuttings that is semi-solid. Yes, you're going to have some fluid in it, but as I move along, that's something that I can load into a dump truck or a roll-off box and can be easily disposed of, dependent on if I need a toxicity characteristic leaching test because of where we're drilling, where this green space is, where this parking lot, this brownfield. Some states, nobody asks a question and it ends up getting taken somewhere and it's gone, and it's ignorance is bliss. And then there's other places where we're going to go, wait, where did this go? And how did I just become a co-generator that contributed? And that's a big piece to this, is our universities and our greenfield sites and these places that we want to do a thermal network. Whoever owns that property is the EPA number that I want to be co-generating with, and not saying it is all on me as a contractor. Spent 4 years with Suez and Veolia, and boy, are they really good at disposing of stuff at a certain cost. Every time it was a co-generator, not I'm the generator because I'm making these cuttings. So that shaker system, and I know I'm blowing through this, folks. It's an hour talk, and we wanted to talk mud and solids control. We have 2 styles. We have our hydraulic mud puppy style, mud slayer, edge systems. They're a low G hydraulic. It's like running on an elliptical. It is flipping those solids down. You have a big coarse screen. The alternative is high G. This is going to require a solids control system that runs a generator, and that I can exert those high G linear forces through frequencies of an electric motor. And that allows me to have finer screens and remove more fluid to reuse. Hydrocyclones, we use 5 and 6 inch, predominantly 5 inch, which is actually a desilter. The idea is to get more of those sand-sized particles out that are hard to settle. How do we do that? They come in the inlet, they make a cycloning effect. It moves the clean fluid to the outside and basically drops the dirty fluid out. So when I have a hydrocyclone running at 75 gallons a minute and it's optimal, it's going to give me 80% clean fluid back to the rig. It's going to give me 20% fluid that is undesirable bad stuff that now we try to run over a screen to catch some of it out. But we should understand with cones running at 75 gallons a minute, 12 to 13 gallons is going to generate waste that we need to be ready to dispose of. Again, here is a 5.5 inch, 400-foot hole. There was 4 of them, 600 feet. That's a dump truck. That's what I need to be thinking about. How many pickup truck loads, dump truck loads a day am I producing on site? And that gets right into, what am I disposing of? Am I disposing of a big fluid? Am I disposing of a fluid pile, a small fluid pond, a box that I need to hit with something, and then some semi-dry solids? How can we get there? What can I reuse? And I look at my disposal options. And again, dependent on the size of my site, what I have for a budget, there's centrifuges. They're becoming way more cost effective than they were. We have vacuum trucks, and we either buy one or we love the company, or we ask the site management company to handle the vac trucks. Filter bags are a terrible idea at this point, though they keep popping up, because if I'm building drilling fluids with fine solids, they're always going to plug that filter bag. Filter containers, there's some great ones out of Houston, Texas that are making it easy for us to separate solids, but I still need to know what I'm going to do with that concentrated solids and then the effluent that I'm creating. And filter presses, this is a filter press. What do we have that isn't even brand new? Because I field tested it in the middle of the Atacama Desert 12 years ago. We have many chemical disposal options now. And there's flocculants and coagulants and different ways that we can break out bentonite and solids and get back a clear effluent. This is not a water. I do not want to drink this. However, I can mix it back into a drilling fluid, be it a foam or a bentonite, and reuse it, and it will bind up any of the extra, cations or things that would have made it. And this makes it so that I could reduce the amount of fluid that I'm using on a site. And we talk about being environmental stewards and having this green, great idea. Again, if I can say I can use 50% less water on this site, what does that mean for us? Right now, maybe not as much as it will in 5 years. In California, in the Western United States, Colorado Compact, right now, hell yes, this makes a big difference in doing geothermal in the Navajo Nation or not. Centrifuges and chemical. It's a great way. Ritchie Brothers, I see centrifuges pop up all the time from these big caisson companies that are gone. There are wonderful combinations that we can do with alum, different coagulants, flocculants. All the major fluid companies have a oil field group that has now, again, NSF approved chemicals that will allow us to do this, that are full of batwing and eye of newt or whatever they put in them these days. But there are ways that we can get back to having a lower disposal cost than just having that 10 cubic yard vac truck show up and it takes 7 away, which is about 1,500 gallons. And where are we next? So ultimately on that disposal plan, we have to follow the state and local regulations. We're pushing to be the best renewable energy. And that means obviously our drilling phase has to do that. That could cost us, but we need to know that information. How are we going to contain our centralized? I see lots of ponds. And then I ask myself, it's spring, it's going to rain. How much of free water are we putting in there? There's a lot of different disposal discussions that we need to have. Hard part with a good drilling fluids and solids control program is, the solids content is determined on what our cost is going to be of how I turn it into a solid. So that's why I want to use it until it's spent. And a good drilling program can have us have that discussion. What do we need for our drilling fluid properties to maintain production and not damage equipment? How do we dispose of that clear water breakout? And it can't just be, hey, it's clear, I'm going to run it in a stormwater drain. Yeah, and working for Veolia, I've seen all kinds of shit come through and go, wait a minute, where's the construction site? And who do I need to talk about this this sodium blue bentonite that is now coming through our system? All disposal methods are going to require time, and that's going to be the expectation we have to have. This was a whirlwind. I made it all up. I think we have time for questions.
We do, Brock. Very interesting presentation. I expect that we're going to have a lot of views of this recording because there's quite a lot of content and a lot for us to learn for sure. We do have a question. This was posed around about 20 minutes ago, so it may have been about an earlier slide, and I apologize if I mispronounced your name. Sukanya, I believe, asked about the rod size. What is the rod size that you were talking about? And I'm not sure what slide that was referenced.
So I referenced a 3.5-inch diameter rod size. Predominantly, if you look at the rigs that we're running, lots are 3.5-inch. If we're going to do smaller boreholes, we think we're going to run a 4.5-inch drill rod so that we have more fluid output, through that rod. There's better tooling options out there that can give us a 3-inch or 3.5-inch rod with a full throughput. The BR50 rod has a bigger throughput, but that annulus is very important for us to maintain good uphole velocity, but also allowing cutting sizes. And so there's a very slim balance there, and there's great oil field drilling programs that'll basically say, I can run this 4.5-inch bit with X size rod. If it's a 3-inch rod, it's optimal. 3.5, we're getting really tight. We have an opportunity to stick tooling in the ground, and that becomes very costly. And so it is a balance. And as we look at going to 600 feet and the amount of solids we're going to process, we need to maximize a borehole that allows for good drilling efficiencies and the right amount of grout and getting it in. And it's sometimes smaller does not make it cheaper when the risk is increased.
Okay, that's a great.
Perfect. Thank you. You call me right, Sukanya. That's my name, and call me Sue.
Thank you very much. I don't like to mispronounce people's names, so I appreciate that feedback. I don't see any other questions right now, but I do have a question for you, Brock. And maybe as I'm asking the question, the others will come in. You mentioned we're continuing to see deeper boreholes. I understand that New York just lifted their 500-foot maximum requirement. So I assume as we go to deeper holes, we're going to have larger diameter pipe, which means larger diameter holes. Is there a calculation or cost-effective strategy where there's only so deep we can go before we have so much solids to deal with that it's not necessarily cost effective? Do you have any thoughts on that?
So I see all sides of this because I see we're small footprints, so we want to go deeper so that we can get what we need out of that thermal footprint. I think the biggest thing that we need to consider, we can drill to depth. We can get the right rig, the right tooling. If it's a very small footprint and we're going to use a smaller rig, we can't look at our same as our large scale production jobs of, I'm going to get, 1,200 or 1,600 feet a day drilled because the fluids change quite a bit. Going deeper, we may have a point where we have to trip all the rods out to change the bit we're going to use to maintain good penetration rate. However, I think the biggest thing, and you could talk with Tyler, with GeoPro or any of the folks, what we pump to bottom and how we displace that open hole. So our grout, right now, our trimming line we like to use is 1 to 1.25 inches. Sometimes now we're seeing 1.5 inches. But if we think we're going to do a 5.5 or 6-inch hole, and then we're going to run in a smaller trimmy, understand that we're pumping under pressure that thermally enhanced grout with bentonite and graphite or cement and graphite, and it's under pressure, and we need to displace it out of the borehole. That's going to change our grouting practices. That's going to have to go back to being able to, extract the trimmy as we bring grout out of the hole so that we don't have that big hydraulic head. But I think the big piece is what is the percent solids of the grout we want to pump, the pumping time, because that's in the oil and gas industry or the mining industry, when we would abandon, these deep holes that we were doing for gold and lithium and these other types, when we'd go in, there was a lot of calculations and planning on what piston pumps, what I was using, how I pumped it, how I staged it out. And, we've been pretty fat and happy with this 300 to 500 range, where all of our grouts have done pretty well of displacing everything out of the hole. And we have this great grout column protecting Mother Nature and making sure that we've given the right, consistency around our loops so that we don't have any air pockets or voids. And, we have the best, system possible. The deeper we go, we're going to have to take into major consideration on all of that it takes to pump and displace and seal that hole properly.
Great. Thank you so much. It's 33 minutes after the hour. Do you still have time to take a few more questions, Brock? Okay.
I do.
Great. So Bill says, not being a driller, there are many terms I wasn't familiar with. Is there a good glossary of terms that can be made available with the recording? Do you have any suggestions for where we might find something like that?
Yeah, I teach the drilling week for the hydrogeological field camp for Western Michigan University, and we have a running glossary. I'll get permission from them and put it up. It is very funny that from, cowboy hats to stocking caps in this industry, saying the word, we're going to trip out right now, or, we have a boot, or we definitely have made a secret society of slang that you're like, gosh, I hope I'm saying the right thing right now, especially when somebody goes, hey, who's got the dope on site? And, some states that it's okay. We're talking about rod dope,
Good point. Okay. Once I hear back from you, Brock, we'll post that. Terry doesn't have a question, but he does have a suggestion here that this recording is going to make our lives easier. We should send a link to architects and GCs who want to know how bore fields are drilled. So I definitely agree with Terry on that. John has some comments and questions here. Utilities are getting into the game, and we're looking into putting boreholes in the right of way. Fluids and cuttings management will be a bigger and bigger issue, and in dense urban environments, in the streets. Interested in opinions in the environment that could help maintain throughput. I realize it depends, but just go for it.
So what's awesome about that question is the gas line industry has been putting cathodic protection deep hole anode beds in the right of way for about the last 20 years. And so from a right of way standpoint, a lot of folks, including the stuff I did in the West Chicago suburbs for Nicor and Kinder Morgan, was all in these great big right of ways between these massive mansions where they had actually moved their space out into having gardens and whatnot. And so we can manage those expectations. It's going to be, we got to be good neighbors. So we're going to have to mat those jobs. We're going to have to just plan on having full containment with straw bales and, silt fences and having a vac truck on site. These are the added costs, but as we grow in success, we definitely don't want to have people jogging or using the bike lane and coming through a giant pile of drilling fluids or cuttings or that stuff. And even to the point of in the Pacific Northwest, some of the exploration stuff we did in some very unique areas, we had noise mitigation. You look at kind of projects that happen in Denver right now, they're fully contained. It's going to cost us more, but, also going beyond 1.5 degrees Celsius and our planet catching on fire, that's going to cost us a heck of a lot more. So it's where do we go from here? But the right of ways, the contracts and the paperwork and how we do it is there. We just need to communicate with our utilities about it.
Great. All right. It looks like those are all of the questions we have now. I really appreciate your time, Brock. Thanks everyone for joining our Dig Deeper on Friday. I hope you all have a great weekend, and let us know if we can do anything to help. We appreciate all of your support of IGSHPA. Thanks so much. Take care.
Thanks, everybody.